Because the normal curve is so important to statistics, you need to understand it pretty completely. So in this presentation, we're going to try to give you many illustrations about how the normal curve can be accessed.
Remember, if you think about the normal distribution, think about the distribution encompassing 100% of the observations falling under the normal distribution. We'll now break the distribution up into various segments and see if you understand and can relate what you see on the distribution. For example, with a normal distribution,
we know that 50% of the distribution is to the left,
which would represent the 50th percentile. But let's take the distribution now and let's insert some points. We put in the mean in the middle and we put some standard deviation units. So if you would, we now have number of standard deviation units that any score happens to be away from the mean. The z-score and the standard deviation are exactly the same. Using this information and the z-table and the figure that you've seen in a previous video, we can estimate percentiles or areas between certain points very easily. For example, we know that 34% of the observations fall between the mean and one standard deviation above or below the mean. So we have that information illustrated in the figure. If you look at that, 50% of the observations fall between the mean and negative infinity. 16% fall one standard deviation or below, and 2.5% of the observations fall at 2 standard deviations below the mean or below that point. Similarly, we could do the same kinds of things on the right-hand side. So, for example,
84% of the scores fall positive 1 standard deviation above the mean, and 97.5% fall below 2 standard deviations above the mean.
And we illustrated before that 50% of the observations fall below the mean. Well, in fact, 50% of the observations fall above the mean. So we could use that information to look at areas in a different way. Here we see the same graph we saw before. 84% of the observations fall from 1 standard deviation below the mean to positive infinity.
Similarly, 97.5% of the scores fall from negative 2 standard deviations below the mean to positive infinity.
And what if you're 1 standard deviation above the mean? You're at the 84th percentile. 16% of the observations are higher than 1 standard deviation above the mean. Let's take a look at some other characteristics of the distribution as well. What percentage of observations fall between plus or minus 1 standard deviation?
34% plus 34% equals 68%.
So the mean plus or minus 1 standard deviation represents 68% of the scores in a normal distribution.
What about between negative 2 and positive 2 standard deviation?
What percentage of observations would fall here? Well, you could add up the numbers, but it is 95%. So the mean plus or minus 2 standard deviations represents 95% of the scores.
In a normal distribution.
Technically, it's 1.96, a number that you're going to encounter many times throughout the remainder of your textbook, but we just round it to 2. Here's another picture of the z-table you've seen before. Remember, down the left are z-scores in whole numbers and tenths, and numbers across the top are z-scores in hundredths. The numbers in the body of the table are percentages, the percentage of observations between the mean and any given standard deviation unit. For example, as we've just seen, going up 1 standard deviation results in 34% of the observations. There they are, those 34%. So you can use all of that information in a wide variety of ways with a normal curve to identify the percentage of observations that fall within any area under the curve.